All right. Fun fact. This is weird, you guys. Most of the elements in the human body were created in the core of a star. So it's kind of this like cute little funny thing that people say, but it's really actually true. You, yourself, and everybody else around you are really just made of stardust. Okay? Everything that is on Earth is just made of stardust. All of the elements up to a certain point, we're going to talk about that in just a minute, come from the core of a star. It's kind of a funny way to think about things, but it actually is true. Yeah?
So if the sun went out, is the sun big enough to create a supernova?
It is not.
So if it went out, it just collapsed?
No.
Because
it will not. It'll get big. It's going to turn into a red giant, and then it will collapse.
But if it went out, it's not trying to blow itself apart anymore, so where the gravitational pull just pulls back.
So we'll talk about the life cycle early next week, but it's a super good question. Basically what happens is there's an addition of radiation pressure that pushes out first. And so the star gets really, really, really big. It's going to get out to the orbit. They're not exactly sure, but it will definitely engulf Venus. It very well may engulf Earth, or we'll get really close to it. Okay, so we won't be around to see that. Okay, because if it's going to get too close, we would die. Like it'll be way too hot. Okay, and then the outer part of the sun will go out, and the inner part will collapse down into a brown dwarf. Yeah, brown dwarf probably, but we'll talk about that. Don't worry about that yet. Okay, but soon. What's that? You're totally going to worry about it? Yep. Or you totally won't? Don't worry about it yet. Next week you can worry about it. But very good question. All right, here we go. We're going to take some notes here. This is quick stuff. What is a star? You know this because we've been talking about it. We just need to write it down formally so you've got it. So what is a star? It is a huge sphere of what? Plasma. For sure, it is plasma. It was certainly a gas initially as things were moving around in the universe. But as it coalesced, that gas came together and the pressure increased and it heated up. And so that gas then turned into a plasma. Okay. A star produces its own heat and light. And as we've talked about, to be clear, everything that has a temperature over zero Kelvin, produces light or produces electromagnetic radiation. But the light of a star is in what part of the electromagnetic spectrum primarily? The visible part of the spectrum, yep. And there is light from the sun that is UV, right? And there's some that's infrared. And there's really, honestly, a little bit of everything. But the majority of the energy is in the visible part of the spectrum. Okay. Is it accurate to say that stars are on fire?
Well,
if they were on fire, that means that they are consuming things to turn to plasma. And that is not true in this case, right? We know that the light comes from, we'll write it down again in just a minute, comes from nuclear fusion, right? So one thing that I want to make sure that you have written down here is that stars are not on fire. They are not on fire. Okay. What's the closest star to us? The sun. Absolutely. You know that. The sun is the closest to us. How far away is the sun? You can just write it right in that same section that you're in. This is a little bit of added information. The closest star to us is 93 million miles, something like that. I'm going to talk about it in terms of distance for light to travel because it's easy to think about that. It is 8.3 what? Light minutes. That means that it takes light 8.3 minutes to get to us from the sun. We've talked about this a bunch of times, right? This means that the light that we see right now left the sun 8 minutes ago, right? And if the sun, for some reason, not according to our astrophysics, idea of what's going to happen, if it for some reason just went out, we would not know for another 8 minutes because the light's still coming, so it would stop 8 minutes from whenever it goes out. The sun is the closest star to us. The next closest star, does anybody know the name of that one? It's okay. It's called Proxima Centauri. I know, right? I'm not going to quiz you over that. That's not something that you have to remember and memorize and recite. That's not my concern. But I do want to just give you a sense of how far away the next closest star is. Okay? Proxima Centauri is the next closest star to us after our sun. Okay? And it is 4.2 light years away. It's not closer than the sun. It's the next closest, right? So it's after the sun. If we were going to go to another star, it would take 4.2 light years. That means that when you look up in the sky and you look and you see a star, if it happened to be Proxima Centauri, okay, which is the closest one, the light that comes to your eyes left that star more than 4 years ago. So that means that you would have been in, 5th grade? So the light that left that star left the star when you were in 5th grade. And it's been traveling ever since then to get to us. Okay? That's the closest star. Okay? That's kind of weird. What galaxy is Proxima Centauri in? Anybody know?
That one? Mars.
It is in our galaxy, right? Remember the Andromeda galaxy, and I ask this because it is important because I want you to kind of get a sense of where we are in the universe, right? We are in the Milky Way galaxy along with billions of other stars. One of them happens to be Proxima Centauri. That's, again, the closest one. So it is in the Milky Way with us, okay? The Milky Way is really, 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 really big. So some of the stars that are on the opposite end of the Milky Way, okay, are hundreds of light years away. I can never remember the numbers. That's why I'm walking back here. So Andromeda is about the same size as we are. It says that Andromeda is 65,000 light years in diameter. Let me say that again. 65,000 light years. So even if it's half of that, because we're kind of in the middle of one of the spiral arms, light from the other side is more than 35,000 light years away. Or it takes 35,000 years for that light to come to us. And that's a star in our galaxy. Okay? It's kind of weird. All right, let's write down a couple more things about energy of the stars. Here we go. Where does the energy come from?
No.
It comes from photons. Photons are the energy, right? What causes that energy to be created?
Fusion, she said that.
Fusion, right? Fusion. And what is fusion? What'd you say? Hannah, you said something, didn't you?
Protons, electrons,
Yep, the hydrogens come together. Yep, so let's write some of this stuff down. So the energy of the stars comes from nuclear fusion. Okay, so this is in that second section in your notes. Okay, just to remind yourself so you don't forget that nuclear fusion is when atoms, or really in this case, it's just the nuclei. What are nuclei? It's the plural of nucleus, right? So you have one cactus, you have two cacti. You with me there? You have one nucleus, you have two nuclei. It's just the way we pluralize it. That's all it is. Atoms or nuclei come together and they fuse, okay, to form heavier elements. So the example that Hannah gave is the example that I have written down on my notes as well. So you've got one hydrogen, you've got another hydrogen. Remember, hydrogen is just a proton, so you've got a positive charge and a positive charge. Do the positive charges want to hang out together?
Yeah.
No! They have no interest. They're like, see ya, I don't want to be together. But there's a bunch of, what's that word that starts with P? There's a bunch of pressure pushing them together. Eventually, it gets so high pressure that those nuclei are going to fuse. They fuse together, and they become what? What do we call that? Do you remember? Helium. There it is. They create helium. Now, here's the weird thing, you guys. When you were in elementary school, you would do word problems like this. If I have 3 apples and you have 4 apples and we put our apples together, how many apples do we have?
2.
That's what I said.
Wrong answer. 7 would be the correct answer, yes? Okay, that makes sense. And math should work that way too. If I have 6 kilograms of something and you have 1 kilogram of something and you put them together, it's going to be 7 kilograms. Stop. Stop. I don't want to do this. I don't want to fight with you because I'm trying to make a point. Okay? You're distracting, and for some of my friends, they need to be able to focus on this to understand it. Okay? Please and thank you. I really want to make this make sense. This is not a trivial thing. I have 6 kilograms of something. I have 1 kilogram of something. I put that together. How much should I have? It should be 7, shouldn't it? That makes sense. But in this case, it doesn't actually happen that way. It's weird. It doesn't make sense. The mass of helium is less than the mass of these 2 things put together. That's the face I wanted, she said. These 2 things added up are heavier than this one. That means there's some leftover something, right? That leftover mass turns into what? A photon. It turns into energy. There is energy that is given off in the form of a photon. The leftover mass turns into energy. Remember, E equals mc squared, doesn't it? That leftover mass, or that mass that's different, is turned into energy, and that energy is given off in the form of a photon. Okay? Nuclear fusion happens not only between 2 hydrogen atoms, but it can happen between larger and larger and larger atoms as well. Okay? You guys have seen this before, right?
Yeah.
What is it?
Periodic table of elements.
Right, you're like, I can read. Sweet, I'm set, right? Yes, it is the periodic table of elements. This is all of the elements that we know. Okay? So that means that every single one of these things that's up here describes a different kind of atom. And each of them, if you notice, there's a 5 and a 6 and a 7 and an 8. You see how those numbers all just kind of keep going and going and going?
Yeah.
Those numbers indicate the number of protons in each atom. Okay? And I know I'm teaching you something new today, right? So here, hydrogen, this is the one we've been talking about so much. Hydrogen has how many protons in it, guys? 1. But you put 2 of those together and you get helium, which has how many? 2. And then you could take a helium and you could put a helium with a hydrogen, and then you'd have how many? 3. And then you could get lithium. And do you see how this works?
Yes.
And so the funny thing is that at the core of the sun It starts off with just hydrogen plus hydrogen is helium. That lasts for a long time, but eventually you've got a bunch of helium that's left. And so then the helium will fuse with more helium, and it will build more and more and more. So you'll end up getting carbon, and you'll get oxygen, you'll get fluorine, you'll get neon, you'll get all of these things, all the way up to, does anybody know what Fe stands for? I heard somebody say it. What was it? Iron.
What?
Okay? It goes all the way up to iron. So here's the weird thing, is that this nuclear fusion, okay, it creates, I want a different color. There we go. Creates heavier and heavier nuclei, okay, from helium, which has 2 protons, all the way up to, I know it's weird that it's Fe, isn't it? It's from Latin. Ferrous, yep, ferric. It's iron, like the iron and the steel that's in your car, that is in so many of the things that you use for structure and things like that, okay, which has, let's go back and look and see how many protons we're talking about here. 26. That's a lot of protons, right? Every time this happens, more energy is given off. Okay? There's another fancy name for this nuclear fusion that happens, that really describes what's happening here, and that is, word for the day, here it is, Nucleosynthesis. Nucleosynthesis. Go.
So with the fission, when it goes
Fusion. Yep.
When it goes from helium to iron, so basically when it's adding on protons, it gets heavier, so it can't move as fast, so it cools down, then it becomes a solid.
So you could have plasma iron. Like, it is possible. That's a really good question. The funny thing that does happen is that the amount of energy that's given off from hydrogen fusing into helium is much, much higher than the amount of energy that's given off when we fuse to get iron. That's why iron is the last one, because it's the last iron, or the last one you can get. What's what? The heaviest element ever? The heaviest thing that we know about is RDG. I can't remember what it's called. Yeah, but it's a man-made element. It's not something we find naturally. Yeah. All right, ladies and gentlemen, have a fabulous day.